Hello, in this tutorial on C++ I want to show you the void pointer. Okay, today when there are other choices like inheritance and templates, the generic programming with the void pointer is quite rare, fortunately. Okay, but in the time of C it was very common. There is a few function that use this generic programming in the standard library. I think this one of the Q sort and the others some binary search, or I don't know, something like that. Okay, first is I know that Q sort is, I'm sure that it uses that technique. Okay, for now we just want to copy an array to another. So create an array, an int array, so 10 element, and the other has 10 element as well. Okay, and now we just call the function which we will write in a second, copy array, and we will pass parameters like a, b, so the two array, and this is not enough. We have to put two more parameters. One is the size of the element, so size of int, and the other is just how many elements do we have. This is 10. Okay, now we just write this function, so copy array, and it's wait for an not void pointer, because as I said it will be a generic algorithm. So void pointer a, void pointer b, and we need a size t, although I didn't talk you about the size t parameter. It can be an int if you really want. It is just the size of return with the size t parameter, not integer, although it is castable. Okay, call it, I don't know, size, and we need a third last. This will be the element parameter, so int element the. Okay, now we only need to write the algorithm. Okay, we use first we have to calculate how many bytes this entire array is. So we will use the size of times element. So size of size times elements. Okay, like that. Okay, so we just multiply these two elements. Okay, we just multiply these two numbers, and with it we get how many bytes the entire thing is, because the size t will give back the size of an integer, so it is 4 in this system in bytes, and then the 10 elements, so the entire array is 40 bytes. Okay, we use a for loop which goes through every byte and copy it. So for int I equals 0, I less than bytes, I plus plus, like that. Okay, and in this for loop we actually do the assignment, but actually we have to do a little ugly thing. For that we have to cast it very powerfully, so very dangerously. We use the reinterpret cast for that. As I said, you should avoid the reinterpret cast, although in this case we will not. You can use the C style cast if you like in here. Okay, we cast it to a char pointer and we get the ith element for that. So how many, so the ith element, and we make it equal to static cast const char. Oh, by the way, the b should be const, just to make everything clear. Okay, I and b. oh, I forget it here as well, so I. Alright, that's it. Okay, so first we convert this void pointer to a char pointer. We know that a char has exactly 1 byte. Okay, and then we just simple copy whatever in this byte to this byte. So in this case, to copy an integer, we need 4 cycles. So 4 cycle. To copy an entire integer, we copy byte by byte. Okay, and that's it actually. And now we should put elements to the array before we, so before we copy it. Make ai equal to I. Alright, and then after the copy we write out the b. So int I equals 0, I less than 10, I plus plus, and just write out the bi. Actually write out, not just be here. So std : count. Okay, and then just make a new line, so separate everything. That's it. Okay, so these for loops will go until it reaches the end of the array, and it goes byte by byte. Every time we use a casting, a very powerful casting and a very dangerous casting, to cast this void pointer to a char pointer, and then because we know that a char has exactly 1 byte, we get the ith element from that array. Alright, I think everything is clear. So okay, there is something problem in here, as you can see, because we get a lot of weird numbers. Alright, the problem is caused by let me think. Oh, I know. First I have because we copy something to the b, so the first is the b and the second is the I, so we just copy some undeclared values. Okay, so yeah, I screw up. It would be easier to just change the parameter, so make a to here, but not really matter. Oh, what am I doing? Here should be the const. Okay, yeah, I should just swap these two things, so it would be easier, but never mind. Okay, and as you can see, it's copied all of the values. So that's about the void pointer. It's not really too good thing. In C++ you should avoid it, but there are a lot of code out there which use the void pointer. For example, the GTK we did here, or the callback function use a G pointer data, which is the typedef for void pointer. So yeah, a lot of code use is this technique. Okay, and if we are here, and I hope that I have time, I want to show you the typedef. Okay, let me see. Okay, I show you. So typedef is a pretty simple thing. The only thing is you give an alternative name for something. For example, in case of void pointer, if we are here on GTK, let's see, make a typedef and make the void pointer and make it into G pointer. Okay, that's it. Okay, and now whenever we want to create a void pointer, we just use the G pointer. So G pointer data, like that. Okay, and as you can see, it is compilable, not give any error. So this is the same as we would write a void pointer here. Okay, make an unsigned int uint. Okay, so I think if I write uint something equal 10, then it would work. And just write out the something. Okay, that's it, and return with 0 because that's a good habit, right? Okay, let's see, and as you can see, it writes out the 10. And if we are here, let's see what the -1 do with something that is unsigned. I think it will give the biggest value, which is not so. This is will give the biggest value, I think, that it can store. Yep, it is the biggest value that the unsigned int can store. This is double of the normal int. So that simple is the typedef and the void, and I promise that I will make a video because of the GTK. So thank you for watching and have a great day.